Okay, so we've completed questions 1 to 5 already in class and in your lab manual. Well, question 6. The question says the molecular weight of the amino acid alanine is 89. So we can immediately write down something based on that information, and that's that 1 molar is equal to 89 grams in a litre. And we're able to write this down because the general equation that 1 molar is equal to the molecular weight in grams per litre. So we have that information. But question 6 says, how many milligrams are present in 30 millimoles of alanine? So we need to get to millimole rather than be at the full molar. So what we can do is add 1 millimole is equal to 89 milligrams per litre. So what I've done there, you see, is I've added a milli each side. So we've 1,000 times less of the molar to milli, and we've 1,000 times less of the alanine being added to the liquid of the litre, the volume of the litre. So by doing this, we have everything in milli. And the question says, how many milligrams are present in 30 millimoles? So 30 millimoles is equal to, and now we just have to multiply 30 by 89. So 89 times 30 is 2670 milligrams per litre, because we're still in the same units as above. So the question said, how many milligrams of alanine are present in 30 millimoles? How many milligrams are present in 30 millimoles of alanine? And you can see that there's 2,670 milligrams is your answer. Okay, so that's question 6. If we leave question 6 over here, and we say that we will question 7. With question 7, it's something similar. It says the molecular weight of the amino acid alanine is 89. So straight away, I can write down the same information, 89 grams per litre. Right? 1 molar equals 89 grams per litre. How many grams are present in 45 micromoles of alanine? So I'm going to do the same trick. I'm going to say 1 micromolar, so I add that, is equal to 89 micrograms per litre. But the question says in 45 micromoles. So 45 micromolar would be 45 times 89, which is 4005 micrograms per litre. So we've got an answer, but the question stated how many grams are present. So if we take the 4005, we need to go back 6 decimal places, because micro is 10 to the power minus 6. So we need to divide by a million. So 1, 2, 3, 4, 5, 6. That's where we leave our decimal point. So the answer would be 0.004005 grams. Okay? And that would be our answer for question 7. So that's brought us 6 and 7, which are kind of quite similar. If we look at question 8, how many micromole are dissolved in 1 litre of a 30 micromole solution? So if it's 30 micromolar solution, it means that it's got 30 micromole, and molar is always per litre. So the question actually here is it's kind of almost like a trick question in a way, because it's quite straightforward that it should be 30 micromoles. Right, so that's question 8, an easy one. If we leave question 8 over here, and we start then question 9. Describe how to prepare 500 mils of a 15%, and WV is weight per volume, sodium bicarbonate solution. Now you'll see here there's no molecular weight provided, it's percentage. We're not talking about moles, we're talking about percentage. So I want you to think about your exams. An exam result you get when it's percent means out of 100. And it's the same here. And you should be able to write down a key equation whenever you see this idea of percentages. And that equation is that 1% is equal to 1 gram in 100 mils. You see? So we have a weight in a volume. So that's the WV that we've seen in the question. So you can always write down that equation. 1% is 1 gram per 100. So let's look at the question. It says 15%. So even first we can say, well, we know that if 1% is 1 gram in 100, 15% is 15 grams in 100 mils. Right? So we know now what we would do to make up 100 mils of that solution. But the question asks for 500 mils. So in this case, 15% would be equal to, well, this is per 100. The question says for 500, so we multiply it by 5, and we'll have it in 500 mils. And 5 times 15 is 75 grams. So the answer will be 75 grams of the sodium bicarbonate solution would be required. So that's fairly straightforward for that question, but please remember that starting equation. That can help you very much with regards to percentages. So question 10, a solution was made by dissolving 7, so I'm going to write it down as I read it, 7.687 grams, okay, of substance X, and that's put into 720 mils. Right, so that's kind of this amount of powder, or this amount of substance X dissolved in 720 mils. And it asks you to calculate the amount of X in grams per litre. So if you know that this is the amount of salt in 720, well, we already know that a litre is 1,000 mils. So how many grams? That's the question. How many grams in 1,000 mils? So everyone will have a different way of doing this, because some of you will cross multiply, so on. What I find is, I know that if I take 720 this side, and I divide it by 720, multiply by 1,000, I'll get this side. And if I do it the same on the other side, take, let me get it, 7.687, and I divide that by 720, which gives it to me in 1 mil, so that would give me the answer in 1 mil, and I'm going to multiply that straight away by 1,000 to get me to the litre. I end up with 10.676 grams, and that's in the 1,000 mils. Right? So the answer will be 10.68 grams then. Alright? So that's question 10. In grams per litre, we would have 10.68 grams per litre would be the actual answer. Okay? So I leave that at that 6 to 10 answered in this tutorial, and we'll look at the next few in the second tutorial. Hope this helps you now in some way. I think just even reflecting on it, the two equations I'd really be telling you really memorize at this point is that 1 molar is equal to the molecular weight in grams per litre, and the other one that was 1% is equal to 1 grams in 100 mil. Right? If you remember those two equations, equation 1, equation 2, that'll help you an awful lot when it comes to making buffers and so on. I think if you want to follow that a bit further, look at Bree Bio. In the molecular bioscience page, you'll see that I have a tutorial about how to calculate some of more of these molecular weight and percentage calculations. Okay.